This is Josh White with JW Math Tutoring. Today's video is going to go over the core skills that you need to learn how to do in Desmos to do well on the digital SAT math section. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Welcome to the core skills section of my Ultimate Desmos Guide to Digital SAT Math. In this video, I'm going to go through what I consider the core or basic skills that you should know how to do in Desmos in order to perform well on the digital SAT math section. So a couple things to be aware of. First, I'm going to be working primarily in the web-based version of Desmos, not in the actual Bluebook app itself. The address for where you find the specific version of Desmos that mirrors the Bluebook version can either be found in the description of the video below, or it'll also display on the screen here as well. Make sure that you're using this version of Desmos and not just desmos.com/calculator, because that version has additional features that are not found and not available in the Bluebook version of Desmos. You specifically want the one that looks like what you see on the screen here, where it says, Desmos College Board, Digital PSAT, SAT version. Okay, next thing, I'm going to be working off a PDF file, basically my Desmos operations file that I give to all my students. And the version that you see on the screen may be slightly different than the version that you download when you watch this video, because I've updated some things or possibly changed the order of some things, but it should still look very similar, in general. But just be aware of that. By the time you watch this video, this PDF file may have changed slightly, and of course there'll be a link in the description of the video as to where you can download this file. Okay. The next thing is I'm also going to be going through example problems in these various Desmos videos. Most of these problems came from a worksheet that had over 100 Desmos practice problems on it that was passed to me from another tutor, but the tutor did not remember the name of the person that created the problems on this worksheet. So if I knew who that person was, obviously I would give that person credit, because most of the problems are from this worksheet. There are some others though that I basically just made up on my own. Um, but you can also find a link in the description to a PDF version of the worksheet problems as well. Okay, example problems. So if you want to work on them exactly as I'm going through them in the video. All right. So with that being said, this, again, here we assume that you have some basic working knowledge of how to use Desmos. If you do not, you should go back and you should watch the introduction video, which comes before this in the playlist. But otherwise, let's go ahead and get started. All right, so I'm just basically going in order, of my skills, Desmos calculator instructions or operations, worksheet here. And the first thing I just want to highlight or point out is about converting between fractions and decimals, and also dealing with mixed numbers. So if you want to convert, obviously, between a fraction and a decimal, or a decimal to fraction, first of all, if you type in a fraction, notice it'll automatically convert to a decimal here. You can see it automatically displays it. Now, if you click this button, though, it'll send it back into fraction form. Now, for this fraction, that's not really helpful or useful, but where it actually can be useful is if you have a fraction that you want to reduce. So let's say you have, 114 over 9, okay? So this gives us the decimal equivalent, but if you do this, notice it gives you the simplified or reduced form, 38 over 3. So just clicking this button basically is how you can simplify a fraction or reduce it, into simplest terms. All right. Now, the only thing to mention is basically with mixed numbers. So mixed numbers don't seem to come up a lot, have not seemed to come up a lot on the digital SAT math section. But if you want to type a mixed number, what you have to do is you have to type the whole number part first, then basically what's going to be your numerator or your fraction, and then you have to highlight, basically either with the keyboard or with the mouse, that numerator part, and then hit the division sign, and then, okay, now you have a mixed number, 2 and 3/4. Okay, notice if you press this button, it'll convert it to improper fraction form. Okay, so if you want to convert from a mixed number to an improper fraction, again, you can just click the same button. All right, so that is basically the first thing on our list, just to be, to be aware of, the first kind of core skill. Next, we have percentages. So you can type numbers with a percentage sign, and you can do calculations or actually solve equations with percentages just by typing the percentage sign. So for example, 60% of 36. There's our answer, 21.6. Or you could say, see, X percent of 50 is 35. Now, what you have to use to actually solve this gets into one of the skills later on that we'll get to, which is solving linear equations. But if we zoom out here, you can see there's a vertical line at 70 because the answer to this problem is 70%. In other words, 70% of 50 equals 35. Now, like I said, I'm not really going to go through too many example problems with these, just with these. I just wanted you to be aware that you can get percentages by typing the percentage sign, and you can do calculations with percentages by, actually typing the percentage sign. The next thing here on the worksheet is a very, very important core skill to be aware of. And this is the idea of basically defining a number as a letter in order to carry it over for future calculations in exact form. So what I mean by this is this will take a decimal that you get, the full decimal answer with no rounding or truncating, and it will store it in whatever letter you tell it to. And then you can use that letter for future calculations. This way, you don't have to retype the entire decimal value with like all the decimal places. And like I said, it takes the entire exact value. Even if you were to type out all the decimal places you see, that's most likely still not the exact value because there are other decimal places that the calculator's hiding that you can't see. So a couple places where this could be useful would be in Pythagorean theorem. So again, don't worry about this specific, skill or whatever. But like, let's say you had a Pythagorean theorem question you were solving where, the hypotenuse was 21 and the one of the legs was 14. Okay, so to solve it out, you would eventually take 21 squared minus 14 squared and then take the square root of that, and that gives you some number. So this number is the value of the other leg of your right triangle. So the point is, if you need to do some type of calculation with this number, what you do is you define this as whatever you want. Basically, you can't use lowercase x or lowercase y or lowercase r. Those are already defined. But you can use any capital letters or you can use any other lowercase letters. So I'll just call this A. And now, if you wanted to take this side length of this leg of this right triangle and you needed to multiply it by, I don't know, maybe times square root 3, and then you needed to add something to it, plus 50 or whatever. The point is, you can get the exact value, no rounding, no truncating or whatever, when you solve this problem by defining, by doing the calculation and then defining it as a letter and then using that letter in the future calculations going forward. Now, another place where this is useful might be trigonometry. So like, let's say you want to find the measure of an angle, okay? And you have to do the inverse cosine of 24 over 25. Now, notice this is actually in radians. I need to switch to degrees. Okay. So in this triangle, the angle I'm finding is 16.26 blah, blah, blah. Okay, that's how much that angle is in the triangle. So I'm going to define that angle as angle A. Now maybe, let's say I want to find the other angle in the triangle. So now I could just do 90 minus a to get that value. And then now I want to find, whatever, the sine of, and let's say maybe I'll define this as b. Now I need, to find the sine of b or whatever. Find out what that's equal to. Okay, notice it actually gives me a nice answer here, 0.96, right? If you just had rounded this a value to 16.26 or 16.3 or whatever, or this b value, if you had rounded this to something 73.74 or whatever 73.8, if you when you go to do sine b, you're not going to get this nice answer. You're going to get some other similar answer, but an answer that is incorrect. In other words, the exact answer to this problem is maybe 0.96, and like that's what you would have to fill in if this was, say, a free response question on the test. Okay? So the whole point, the whole takeaway here is you can define values as letters to use in calculations, in later steps and everything. And it's also useful just even if it's not a decimal, just because then you don't have to like bother retyping the numbers. You can just literally type one letter instead of having to retype, the whole value. All right, so now moving down the sheet, the next thing I want to talk about is sliders. So a slider is basically just when you add, I'm just going to give an example here. Okay, so I typed y equals 2x plus b here, right? This is basically going to be the graph of a line, the slope of 2. Now I'm going to add a slider for b, and I can move the slider, and notice it moves the graph, right? Because it's changing the y-intercept value of the line. So a couple different things about sliders. You can either hit the add slider button, or if for whatever reason it doesn't appear or whatever, or if you have a specific value you want to go to, you can also just type. Let's say we want to start at like b equals 10. Okay, and then you can set the upper and lower limits. So let's say I want to check between 10 and 30. And you can also set your step value. This is how much it's going to move, each time you move the mouse, kind of like one tick to the right, one tick to the left. So maybe I only want integer values, so I'll set the step value equal to 1. So notice then it goes 10, 11, 12, 13, 14, boom. Okay, but maybe I now want to look at 10 and 15, but I want the step value to be 0.5. All right, so now notice it's going to be, 12 and a half, 12, 11 and a half, 11. But you can set the step value and the range yourself just by clicking on them and make them go, as high as, or as low as you need to. So sliders are very useful, especially in a lot of type of quadratic equations where like you're using a slider to see what the maximum or minimum value of some constant is, such that say there's like no real solutions or there's at least one real solution, or those kind of things. You'll see, basically we'll get to examples of where you can use sliders to help you solve problems. All right. The next thing I want to talk about is basically the distance formula, which finds the distance between 2 points. So you can either just type distance and then put in your 2 points, put them both in coordinate form, put a comma between them, and it'll just give you the calculated value here. And again, if you needed this value for something, I would just define this as a letter so then I could carry it over for future calculations. Like maybe this is the diameter of a circle and you need to divide it by 2 to find the radius of a circle. Like that's a very common use of the distance formula, is basically taking the 2 endpoints of a diameter, plugging them in, finding out what the distance is, and then dividing it by 2 in order to get the radius value. Now, you can also define points. So let's say I defined this point here, and then just type the letters into the formula instead of the actual coordinates themselves. So here I've defined A, I've defined B, and then this would only probably be useful if you had like, say, multiple points to check. So like you checked this, you got the answer, you see the answer is not right. Okay, so now I'm going to go to answer choice B, and maybe the answer is like 4, 6 with the same, B thing here. And you see that's not right. And then, okay, maybe answer choice C has the same A point, but maybe this is positive 1 or, whatever, and so on. So you can define the points and you can, use it that way, or you can just type the points in themselves. All right, next up, let's talk about basically the midpoint formula, or finding the midpoint between 2 points. So you can do this the exact same way that I did the last problem. You can type in 2 points. Now, the thing is, it's going to show you the point on the graph, but if you want the actual coordinates, you have to click label in order for them to appear. Otherwise, you're basically just guessing, as to what the coordinates are. Similarly to the distance formula, you could define the points as A and B or whatever, and you could do midpoint, parentheses A, comma B. And one last thing just to be aware of is this is really useful when if you have a circle and you're trying to find the center of it. Because basically you would take the 2 endpoints of your diameter and you would find the midpoint between them, and that midpoint is going to be your center. So that'll give you the coordinates of the center of the circle, or your h and k, if you think about the circle equation in standard form. All right, next topic we're moving on to is finding the mean and median of a set of data. So the mean is of course the arithmetic average, basically just adding up all the numbers and then dividing by how many numbers there are. And you can just type mean and then list all the numbers in parentheses. They do not have to be in any type of order. Okay, so here's the mean of this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay, and that's, pretty much it. And you could do the same thing with median. If I wanted to find the median of these 9 numbers, I could just change this to median, and there it tells me that the middle value is going to be 13. Okay, so these are primarily used when you have lists of numbers, like generally meaning not a frequency table, but you have just a list of numbers, and you generally have a relatively small amount of numbers, meaning like usually less than 20. You're not going to spend time typing out, 50 different values or 100 different values to find the mean or the median of them, from a problem. One last thing just to note too, you can access them also from the function menu. So if you click down here, to expand the keyboard and go to functions, and then you scroll down. Let's see, where is it? Why am I not seeing? Oh, here it is, under the statistics, right here. Mean and median. You can also just click them here, but it's much quicker just to type them out, rather than going down there and accessing them through there. But you can get to them that way as well. All right. So now let's get into the first kind of specific problem type that we're actually going to solve. Meaning this is the first one we have an actual example problem from the worksheet. And that is identifying the number of solutions to a linear equation. So here's the example problem we're going to look at. All right. And you can see here, it says, how many solutions does the equation negative 48 equals negative 6? So I'm just going to go ahead and type this in first. Okay. Now, so I've typed the equation in, right? However, if you look on the graph here, you see that there is nothing visible. Okay, there are no vertical lines. So, and if you look in the document here, the instructions I have, right here, it says graph y equals the left side and graph y equals the right side of the equation. So for these specific types of problems where it's identify the number of solutions, meaning not actually solve it, but identify how many solutions there are. And I'll just jump back to the worksheet just to confirm, basically it's going to be 1 solution, 2 solutions, infinite solutions, or all real numbers, or 0, i.e. no solution. those are your answer choices basically. So for this type of problem, I recommend that instead of just typing the equation in, what you do is you graph y equals the left side, and then below that you type y equals the right side. Let me get rid of all this. Okay, so now I have y equals left side and y equals right side. Now I don't see anything on the graph yet, but that's because it's way down here. So if you notice here, and just move this over a little bit, it looks like there's only one line on the graph. And if I turn this off, notice the blue line is directly underneath it. So what's happening here is we have one line overlapping, which means the answer to this question is infinite solutions. Okay, so again, the way we're identifying the number of solutions to a linear equation is if we see one line overlapping itself, that would be infinite solutions. So the correct answer to this problem is just going to be letter C, infinitely many. Now, just to show you briefly how it would be no solution or versus one solution, if I changed the left side number and I made it this, notice now we have two parallel lines. They're both horizontal, but I can show you some examples also with them not being horizontal. The same thing will happen. But here we have two parallel lines. This means there is no solution. So if this is the graph you saw, it would be no solution. Now, if you had two intersecting lines, so let me just change this. Okay, so right here now we have two lines that intersect at one point. Therefore, there is exactly one solution. It's this point right here that I've clicked on. Okay, and just to show you, again, some other examples, say you had one equation that looked like this, and then you had another equation, so it would be y equals left side, and it would be y equals right side. So these there, it's kind of tough to tell when I'm zoomed out, but now when I'm zoomed in, you can see these two lines are parallel. So this is an example of no solution. Now, if I change the problem like this, now we have overlapping lines. Again, see how I unclick the black and the purple here? This is infinite solutions. Same line over top of itself, i.e. the graph only displays one line. And lastly, if I now, let me go back to the original problem, but let me just do this to it. Turn this back on. Okay, now we have the one solution case, intersecting lines, basically, one solution. So this is how you can identify the number of solutions to a linear equation just by graphing, again, y equals left side, y equals right side. Also, one other thing just to mention, when I first did the problem, so when I typed it out, it was -48 equals, just try to get the whole thing again, -6, 2x plus 8, I think, not plus 12, because that's showing something, plus 12x. There we go. Okay. So when I first typed it out, right, notice you did not see anything on here. See, the reason why for this specific type of problem, why I like doing the graph y equals left side and y equals right side method is because no solution, and if you just graph the equation itself in one line, the no solution and the infinite solution cases will be identical. They will both show a blank, empty graph. You can't tell just by looking at the screen right now whether it's no solution or infinite solutions. The only way you can tell is by graphing both lines separately and then seeing, do you have the same line over top of itself or do you have two parallel lines? Okay. All right. So the next problem, or the next kind of topic that I want to go over is very similar to really what we just did here. It's just like it's kind of described or labeled differently, but this is basically now either solving a system of equations by graphing or also identifying the number of solutions to a system of linear equations. Um, so, and they don't have to be linear equations. They could be other equations as well. So for example, let's look next at this second problem here. Okay. So let me just first go back to the sheet. So again, all we're going to do is basically graph both equations, and we can just graph both of them as they're given, and then we're going to look for the same thing that we did in the last one, which is either two parallel lines, one overlapping line, or just a pair of intersecting lines. So let's go here, graph the first equation. Let's graph the second equation. All right, so these intersect once, and it's at this point right here. So technically, this question is only asking for the y coordinate, so the only answer you would report here would be -2. And that's it, because they intersected the point 1 comma -2. Now, similarly to this, we could also identify the number of solutions, not the actual solution itself, but how many solutions does it have. So, for example, here, this question says, which of these systems of equations has no solution? Now, this specific example, you can probably look at this and figure out what the answer is going to be right away, and that's fine. If it's quicker and easier for you to do that instead of using Desmos, like that's perfectly reasonable. But I'm just going to demonstrate how you can basically go through. Okay, so answer choice A, we can see, does this have no solution? No, they intersected this point right here. Okay, next up, answer choice B. We've got the first graph, we've got the second graph. Okay, no solution? Nope, they intersected a point. Third answer choice. Okay, no solution? Yes, we can see here that these are two parallel lines. Okay, so this is going to be the correct answer. And you could go ahead and you could do D as well, but y equals 7 is going to be a horizontal line, and then the other line is just going to intersect it, y equals 7x plus 2 because it's diagonal. So the correct answer for this is just going to be letter C. All right, so now let's take a look at the last operation on this first page here of the core skills. So this is basically identifying, a table of values or like maybe even a single point as a solution either to a graph or a function or an inequality or a system of inequalities. And essentially what you're going to do is you're going to graph the points and or the function or inequality or system of inequalities. You're going to see like if they are solutions or if they are located on the graph or if they're a solution to the inequality, meaning they're in the solution set, they're in the shading and everything on the screen here. Okay, so let's go back to example problem. So here we have a given point, -3, 4. So first thing I'm going to do is I'm going to graph that point, whatever, give it its label. Okay, we see its coordinates, right? This point is a solution to one of these pair of inequalities. So all I'm going to do is I'm going to graph them each out. I'm going to see which one. Okay, this is A. Is it in the solution set for this? Nope, no it is not. Now I'll move on to B. Notice that in B, the first inequality is the same, but the second one just has greater than it. Okay, is this in the solution set? No, here the solution set's on the right, but that's not where the point is. So A is wrong, you cross that out. B is wrong, cross that out. All right, let's check C. Now we're going to flip this, and we are going to let's see, flip this one back as well. So is this in the solution set? And the answer is no. No, it is not. Solution set is the overlapping shading, which is over here on the left. So it looks like it's going to be answer choice D, but let's just confirm. So first inequality is the same. The second one now flips back. Okay, so is this in the solution set for this one? Just make sure it matches up. The answer is yes. So the correct answer for this is going to be letter D. So again, this is how you could identify whether a single point is a solution to, in this example, we did a system of linear inequalities. So there's one, no, it looks like we actually have two more examples here. So let's go through those as well before we move on to the next topic. So in the next one, we have a function, and we can just graph that function, negative x squared plus 4. And now you can start going through answer choice A, and you could do like, 2 comma 0. Okay, is that on the graph? Yes. All right, let's see here. Is 3, negative 5 on the graph? Yes, it looks like it is. And 4, negative 12, have to scroll down a little bit. Okay, so notice all three of these points are on the graph. Therefore, the correct answer for this is going to be letter A. All right, and you could try out the other points for all, the other three answer choices, but you should see that they're not going to be on there. Just to show you like one example for each. 3, negative 13, not on there. 1, negative 3 for C, not on there. 1, 5, not on there. So that just proves that, the others are all incorrect as well. All right, let's look at a slightly different variation now where here you're given the two inequalities. And they want to know which point is a solution. So now we just have to graph out the points. Okay, so it looks like for this one, it looks like it's going to be A, but let's just double check. We'll label this A, negative 2, 1. Okay, notice this is, it's on one of the lines, but it's not in the overlapping region. So would not be a solution. That's B. And you don't have to spend the time labeling this as I'm doing it. I'm just doing it just so you see exactly which one is which, but you don't need to do that when you're taking the test if you already see that they're not in the solution. Okay, so we can clearly see A is the only one that is a solution to this system of linear inequalities. So again, this is just showing you how you can basically find a point or points that are solutions either to like a linear inequality or a system of linear inequalities or located, say, on a line or on a function of some type. Now we're going to move on to the next page and take a look at some more core skills that you should know how to do in Desmos in order to do well on the digital SAT math section. All right, so at the top of the second page, the first kind of topic or skill that you see listed there is linear regression. Basically, what this means is you can for any problem, find the slope or the y-intercept or the equation of a line if you're given 2 points on the line or a point and the slope of the line or given the graph of the line. Now, you can see there under the instructions column, basically what you're going to type is y1 tilde mx1 plus b. The tilde is what you use to do regression. And basically what you're going to have to do first, though, is that you're going to have to create a table and you're going to have to enter in at least 1 point or 2 points, depending on if you have the slope or not. And then it's going to return to you m and b, m being the slope, b being your y-intercept. Now, if you already know the slope, then you can just type that value in the regression statement in place of m. And then it'll obviously just be returning b. Okay, so let's go ahead now and look at a bunch of example problems to show you the different types of problems you could come across, that would use this, basically that would require this skill. Okay, so going through again the example problems here. First one we have, you are given the slope of a line and you're given a point that it passes through. And it asks you for the equation of the line. All right, so first thing I'm going to do is I'm going to create the table and I'm going to enter my point into the table for x1 and y1. And then, excuse me, I'm going to, in the next line, do the regression statement. Now, instead of typing in this full thing here again, I'm going to replace m with the given slope, which is negative 1/2. So now that I have typed this in, I can go ahead and just do the regression. I can see, okay, the value of b is 9.5. Therefore, the correct answer has to be letter B here. Now, a couple things just to point out. Okay, on this specific problem, since you were given the slope of negative 1/2, you should have already been able to eliminate answer choice A and C because they don't have the correct slope, and you'd basically be down to B and D anyways. But this is how you can quickly and easily find the y-intercept value of the line. And let's just zoom out here and see the line a little bit. Here is its y-intercept value, here is its x-intercept value, and you can also see the point that I entered in the table on the graph right here. Let's see here, a couple other things to be aware of. So notice we have the graph now. So you can trace along the graph for points, but one common problem type, which we'll take a look at in a little bit, is finding a value of a point on this new line that we just found. So in other words, what is the y value when x is 4? Or what is the uh, x value when y is equal to 4, to kind of doing the opposite. And you can trace and do that, but I'll also show you how to easily do that, by graphing other lines and other things as well. All right, so now let's look at the next example problem. Here, when you read this, this might not look like linear regression, because you're given some equations basically in function notation. But really what this problem is saying is this linear function, i.e. line, goes through 2 points, basically 0, 4, and 1, 6. So I'm just going to type those in. And they want to know what's the equation that defines it. So now, again, I can just do linear regression. Okay, my slope is 2, my y-intercept is 4, so it looks like the correct answer to this one is going to be letter D. Again, with this one, if you notice that, f of 0 is just going to be the y-intercept value because the x is 0, you could have eliminated A and C right off the bat because they do not have the correct B value. But we can just easily create a table, do the linear regression statement, get the slope, get the y-intercept. So this is an example of finding the equation of a line being given 2 points. All right, so let's keep going and look at some more examples. So here you have, take a second, and read over this next problem. You're told that this line passes through a point, and you're also told that it is parallel to a line with this given other equation. Okay? And then what you're actually asked to find, though, is not the equation of the new line, but the y-coordinate of the point 4 comma something for this new line. All right, so it looks like you have a lot to do here, but it actually will not be a lot at all. So what I'm going to do is first enter in my point. Now I'm going to do the linear regression statement. But what you also have to know, and this is, kind of background math knowledge, is that the slope of this line k that we're trying to find the y-coordinate for when x is 4 will be 3 because it's parallel to y equals 3x plus 8, and parallel lines have the same slope. So that's something, that you do have to know. So we can type in y equals 3x1 and then plus b. Okay, now we have the new line. All right, so we have the new line graphed here. We see b is 1, so the new line is basically line k. In other words, is y equals 3x plus 1. So there's multiple different ways here that you could find the value of d. You could go ahead and you could just, basically type in here, well, 3 times 4 plus 1. And you could see it's 13. Okay, and that is the correct answer. That is what you're going to report. Or an alternate way to do this, and this is actually going to come up in one of the later, this is technically one of the later operations, but I'll just still show it now as a preview. If you type x equals 4 here and then look at the intersection point, here we have the point 4 comma d, which is on this line, and we can just see the y coordinate is going to be 13. Okay, so this is just an alternate way that you could get this as well. All right, let's look at another example problem where we can use linear regression. So you're given this graph here. You want to know what's the equation of this line. All right, so the easiest way to do this is basically to take 2 points on the line, plug them into our table, and then just do the linear regression statement. And we'll get the slope, we'll get the y-intercept. All right, so it looks like, let's see here. It looks like it crosses, right at the grid marks here at 0, -8. And now it also looks like it crosses, and you might have to zoom in Blue Book of it, and if you're in Blue Book, obviously you can zoom in on the graph just to, to make sure. But it looks like it crosses right here as well at -2, 0. So now I can just do my linear regression. Okay, m is -4, b is -8. So when I go through the answer choices, which has a slope of -4, -8? Well, it's going to be answer choice D right here. So the correct answer for this one is D, and you can just see if you look at the graph on the screen here, it looks pretty similar. And you can zoom in if you want to get the window a little bit closer to what's in the provided picture. You can see the graph looks pretty similar in terms of its steepness of its line and everything else. Okay, so just the last thing I want to mention here is that for linear regression, there are all kinds of different little variation type problems that you could be asked to solve. You could, for example, just to scroll back, if you look at this last problem here, you could be given the same problem, except it could have said, if it passes through the point d comma 4, what's the value of d? So in other words, it's asking what is the x coordinate of the point that has a y coordinate of 4, okay? And you still go through the same process or the same steps. It's just the very last step would be slightly different. But basically, the whole idea is if you have a point and a slope, or if you have 2 points, being able to get the equation of the line, meaning get its slope if needed, or get its y-intercept if needed, by using linear regression. That's the main skill. That's the main takeaway here. All right, so now let's go back to the sheet and we look at the next thing on it, on page 2, which is evaluate a function or combination of functions. Or another way to think of this is basically find a y value of a function for a given x value. So these all kind of mean essentially the same thing. They're just different ways of describing it or talking about the problem. So there are actually 3 different ways that you can do this. So just to show you real briefly the 3 different ways, and then we'll look at some problems. Let's say I just defined a basic function here, okay, is f of x. So method 1, I have my function, and then on the next line, I can just do f of whatever, okay? So when you plug in -4 to this function, 12 is the y value that you get as your output. And you can just, do it for any number. Now, the second method to do this is, once you have our function typed in, to go here and go to this option, create table, and it'll automatically populate the table here. You can see with x values coming down, and then with the corresponding f of x or y values, and you can just type whatever numbers you want in here. And it'll automatically update. So this is actually useful if you have multiple values you want to evaluate and plug into the same function. Okay, so this is the second method. Again, I clicked on the gear icon up here and then clicked the Create Table button. And of course, the third method, and this is what I actually showed in one of the problems we just went over, is So I could just type x equals the value and then look at the intersection point, and the y coordinate of that is the answer that you're looking for. So in other words, f of -2 is just 0. Okay, so this is just a third method that you can use. Basically, you graph x equals whatever the number is, and you look at the intersection point. So a couple things to be aware of. This is any of these methods are usually sometimes quicker, easier than tracing along the actual graph itself. And the thing is, the third method does not require you to actually type the function. So what I mean by that is if you do a regression, like I just did, I was just doing linear regression for lines, right? And then you want to evaluate that at, whatever, x equals 4, like I did for that one problem. If you use method 3, you don't have to retype the function. Okay, you can just type x equals 4 and the graph is already there, and then you just go to the graph and get the point. Whereas if you wanted to use the other two methods, you would technically have to type, whatever that equation, that line was, like y equals 3x plus 1 or f of x equals 3x plus 1. You'd have to retype that and then, do f of 4 or, retype that and then click on the gear icon and create the table. So method 3 is very useful if you're doing something with a regression and you don't want to bother retyping the entire function out. However, depending on how large or small your values can be, sometimes on a graph you'd have to zoom in or zoom out a lot. So that's the downside to using method 3. And then just last thing, again, good with some problems, combinations of functions, you just type in, whatever the combination is. So like f of 2 minus 2f of 4 and whatever, that's what it is. And you can also do this, I'll just show you real quick, for multiple functions as well. So we could say f of -1 plus g of -7. So evaluate the first function at -1, evaluate the second one at -7, add them together, you get -31. Okay, so with that being said, let's look at the problems now. All right, so first thing, y equals 3x plus 8. That's our basic function, and we want to know what is the value of y when x is 4. So again, there's 3 ways you could do this. Method 1, f of 4 is 20. Okay. Method 2, create the table, type in 4, f of 4 is 20. Method 3, x equals 4. See it here, you have to zoom out a little bit, find the intersection point, click on it. Okay, what is the answer? The answer is 20. All right, so those are the 3 different ways that you could evaluate this function and get the answer of 20. Excuse me. Next, we have a basic exponential function here. So, you can type the whole thing in. Again, what is f of 1? So for one like this, I would probably use method 1 and just get 60. The problem with using, again here, method 3 is that if you do x equals 1, it's like you got to scroll up a little bit here, maybe you have to zoom out. And also, depending on how far you're zoomed out, the intersection point, like it's not obvious there. When I click around on it, it does show up, but initially it's not showing up, as an obvious, like, clickable point. So again, that's another downside to method 3. All right, so let's do now an example of combinations of functions. So here we have f of x. Here we have g of x. Okay, so I can just type them both in to make sure everything matches. -2x squared plus 3x minus 1. Okay, good. What is 2 times f of 1 minus g of -4? So we type everything in, we get 31. That's our answer. Don't need any more work. You can move on to the next problem. So one other thing just to mention, some other like variations for types of problems where you could use this is where you have translations of functions. So you might be asked to translate or shift a graph in some manner and then evaluate that new translated or shifted graph. Again, I'll get to translations and shifted functions later, but that's another type of problem that could ask you about evaluating a function or combination of functions. All right, so let's get back to the sheet again. We're still on page 2. Now we're going to just look at the opposite, which is if you're given an x value, finding the corresponding y value. And so what I'm going to do here is basically just graph y equals, or sorry, I should restate that. I think I just said that. Let me start over, said that backwards. What we're doing now is we are being given a y value and you're finding the x value that corresponds to the known y value. So for this type of situation, you're just going to graph y equals whatever the number is, and then you're going to look at the intersection point or points, and that's going to be your x value or values. And again, this is oftentimes much easier than tracing along the actual graph. So let's look at an example of a problem. Okay, here you have a given function. Okay, 6x squared minus 5x plus 1. And the question says, for what positive value of x does this function equal 24? So all I have to do is I go y equals 24, and then, okay, I'm going to have to, you can zoom out if you want, but scroll up a lot, and notice there are two intersection points, okay? One of them is a negative value. That's not going to be the answer because the question specifically says for what positive value, and the other one is the positive. So 2.418 would be the answer that we report. That's the positive value of x, which has a y coordinate of 24. So 2.418, that's our answer. That's all you have to do. And you can move on, to the next problem. All right, going back to the operations, reference sheet. So the next thing is very important. This is something that comes up very often. There's going to be multiple problems on, the test that cover solving equations. And specifically, you have linear equations, just with x's and numbers. You have absolute value equations. You can have radical equations. You can have rational equations. It's where you have x's or variables in your denominator. And you can, of course, have quadratic equations as well. So I guess I would say with the simplest method or way to do this is, and this is method 2 I'm talking about first, would be to just type in the entire equation that you're given, and then you look for the vertical line or lines, and those are going to be your solutions. All right, so I'll just show you a brief example here. So here's a basic linear equation, right? I type it in. Notice I don't see anything, but that's because I have to zoom out a little bit. All right, so notice here there is one vertical line, and it is at x equals 10, because I can click on this point 10, 0. So my answer to this would just be x equals 10. Now, here's the problem with using this method. The first issue is that some equations will not return all the solutions. So we're talking like radical or absolute value equations sometimes. And second, and related to this, sometimes the lines will not be clickable. What I mean by that is you'll see the line on the screen, but if it's not on, a nice whole number, a nice integer value, instead, what you're going to see, you're going to have to guess basically what the decimal value is. So in that case, it's preferable to use the method 1, which is what I'm going to talk about in a little bit. So I generally do not prefer method 2. I almost always prefer method 1. But method 2, I mean, obviously it can be used, especially for basic linear, or quadratic equations. All right, so now method one instead is basically to take the equation you're given and set graph y equals left side, y equals right side. It's the same exact technique that I talked about on the first page where I said about finding the number of solutions to, a system of equations or a linear equation. And then you look for the intersection points. The intersection points are your solutions, and specifically it's the x coordinate values that you want. The reason again, that this is also preferred is because for a linear equation, it will make it obvious when it is no solution versus infinite solutions. No solution is going to be two parallel lines. Infinite solution is going to be the same graph on top of itself. Whereas if you use the second method where you just type it all out, it's not going to be obvious because the screen is blank in both of those cases. Okay, so that's another reason why I generally prefer to use method one when solving equations. All right, so let's look at some example problems now. So here is a basic linear equation that we're going to solve for x. So again, I'm going to use the first method. So I'm going to do y equals left side and then y equals right side. Okay, and then I need to find where that's type drawing. That's why the solution wasn't on. Okay, then I just need to find the intersection points. So notice here the intersection point is 221. That means that x equals 2. However, be careful, that is not the answer because the problem doesn't want x. It wants x plus 4. So you do have to remember to take 2 plus 4 and get 6. Okay, so 6 is the answer that you would submit for this problem on the test. All right, so let's look now at another example. So in this next equation at the bottom of the screen here is, see if I can get, yeah, I can get the whole thing on the screen so we can see it. So this equation has two variables in it, c and d, and you could just, change them to x and y. But basically, notice what you're doing here is, it's like, so you say you have 3.5x plus 8y equals 120. So in this case, I'm just going to type the whole thing in as just 1. But now it tells you that d, the number of dogs, is 12. So you can just replace y with 12. So now, basically, I'm just solving this equation, and right here, so here's where you have to be careful. It says, how many cats, can it care for in a given day? So the solution is 6.857, but obviously when we're talking about, number of pets, number of animals that you can care for, we only deal with integer values. There's no such thing as like 0.857 of a cat or a dog. So the correct answer for this question would technically be 6. Okay? Notice it can't be 7 because then if you plugged in 7, the values would be too many. It would be more than 120. So therefore, you have to basically round down here to be 6. And you can't have a decimal value of an animal. So don't worry so much about that part of this problem. Just worry about if you're given an equation with two variables and they tell you what one of the variables is, which in this case is 12, being able to solve that by just typing it into Desmos, and getting the answer. All right, next let's look at an absolute value equation. So here's a problem. This one I am going to go back to using method 1. And then the other one's just going to be y equals 21. Okay, so now there are two solutions here. There's a positive and a negative. It says, what is the negative solution? So the answer to this is going to be negative 7.5. So that is the answer you would fill in if it wanted. And you could also see, of course, sometimes there are problems where it's like, what are the sum of the two solutions to this equation? Then you would add them together, or what's the difference, or something like that. So you can see slight variations on these types of problems as well. All right, let's look at a radical equation next. Again, I'm going to use the first method, which is the y equals both sides. All right, so now again, I'm looking for where these two graphs intersect. So it looks like there actually is only one solution here, even though the question is worded as, what is the smallest solution? It looks like there actually is only one solution. So the correct answer here would just be 8. Now, let's just see if we did it using method 2. Yeah, see, there is only one vertical line, but the problem is you can't click on it. So, I mean, if you zoom in, you can see it's exactly on 8, but again, you don't know that. You wouldn't necessarily know that if it was a decimal, shifted slightly to the side. All right, next, let's look at a rational equation that we want to solve here. So, again, I'm going to use method 1. Again, notice here there are technically two different solutions, one positive, one negative. This question asks for the positive, so we would, of course, report 5 as the correct answer because that's the x-coordinate of this, intersection point right here. We don't care about the negative one. All right, let's look at some quadratic equations now and solving them. So, again, I'm going to use method 1. Y equals left side, y equals right side. Okay, so this one's a little tricky to see. Let me try zooming in here and saying, okay. So this one, notice it says, what is the sum of the solutions? So here are our intersection points. Let's see. I can zoom in to get any more decimals. Doesn't look like it. So if I go ahead and I just do manually negative 1.447 plus negative 0.553. Okay, I get exactly negative 2, which is the correct answer to this problem. So this one you have to do a little work in that you have to find the two solutions or intersection points. Then you definitely do have to take the step of adding them up. All right, now let's go back to the worksheet and let's talk about solving an equation using regression. So here, what you're going to do is you're going to type in the equation exactly as it's written, except you are going to replace all the x's with x1s, and you are going to use a tilde instead of an equal sign. Okay? Now, there's a couple issues, things to be aware of with this. First, the regression statement's only going to return one solution. So to get additional solutions, you have to put in like inequalities basically inside brackets at the end of it, where you maybe make x positive or negative or greater than a number or less than a number, and that's how you get the other solutions that you can add together. Okay, this is useful, very useful for when you have answers that are going to be decimals or when you have answers that are going to be very large, so you don't have to zoom out and scroll a long time on the graph. It's also useful for the Pythagorean theorem as well because you can just type it in exactly as you see it, like 21 squared plus x squared, tilde 42 squared or whatever it is, and it'll give you the value. You don't have to rearrange it and square root it and all that stuff. So first, let's look at this problem. Okay, and I'm just going to go back to method 1, except I got to make all these all x sub 1. Okay, so notice here, okay, it gives me a solution. It gives me the negative 0.553, and it gives me the exact value here. So I have the exact value stored in x1. Now what I'm going to do is I'm going to just use a different x. So I'm going to make it x2. Right, notice it's giving me the same answer, but I don't want that. I want another answer. So what I'm going to do is I'm going to add this qualifier in here that says x is greater than negative point, not x, x2 is greater than negative 0.5. Now, why is it returning? Oh, sorry, no, I want the other. Sorry, I want the other way. I want it less than it. The other one's going to be. Sorry, there we go. I want the other one. I want the one over here that's like the negative 1.447. Okay. So now I have the two exact decimal values stored together. So I could take x1 plus x2 and notice it does equal exactly negative 2. Okay? So I used regression to solve this equation. I technically had to do it twice because one statement gave me the first intersection point here. The other one gave me the other value over here, and then I could add them together by adding x1 plus x2. All right, so now let's look at another example of using regression to solve an equation where it's helpful. So here you have a right triangle, and you might, if you're working on this problem in general, you might draw a little picture. Hypotenuse is 25, one leg is 7. What's the other leg? Okay, X, or you could use whatever letter you want. Whatever letter you want. Like you can actually use A here too. You only have to use the sub 1 if you're doing it with X or Y. With any other letters, you could just use A, B, C, whatever you want. So I've got A squared plus 7 squared tilde 25 squared. Right here, my value of A is 24, and that's it. So no other work, or anything else that needs to be done. So this is how you can use regression, again, to solve an equation. All right, going back to the worksheet, last thing here at the bottom of the second page is translating or shifting graphs. So basically what you're going to do is you're going to enter the original function. So let's say I have like 2x squared, plus whatever, 5x minus 4. And then I'm going to enter the new function, and I'm going to set that equal to the original. I'm going to do the shift to it. So let's say I want to shift it up 4 units. I would do f of x plus 4. And you can see the green is 4 units above the blue. Or if you want to shift it down 4 units. Or if you wanted to shift it to the right 4 units, that's where you put a minus 4 in the parentheses. Or if you wanted to shift it to the left 4 units, you could do that as well. And in addition to finding what a function looks like after a transformation, you can also sometimes you'll have a problem where you'll be given the translated function and you want to find the original function, or you want to find a point or a value on the translated function, after the translation occurs. Like those are all types of problems that you may see um, where you would use, translations. So now let's take a look at some example problems where you can use translating or shifting a function or a graph. So we'll go back to the worksheet here. Got a bunch of different problems to look at, basically all like slight variations, but using the same basic properties. So the first one here, we have a function, and it tells us that this new function is the result of translating the original function down 5 units. What is the value of g of 1? In other words, what is the y value you get when you evaluate this new function for 1? Okay, so first thing I need to do is just type in the original function, f of x, and then I can take my new function and I can just do f of x and then minus 5 because I want a vertical shift down 5 units. Okay, so now to go ahead and find g of 1, all we have to do is just do this right here and we have our answer. It's going to be negative 5, and that's it. Note that you could also use basically method 3, which is to graph x equals negative 1, and then, or sorry, not negative 1, positive 1, and then look for the intersection. I'm going to turn off the graph of f of x just to make it a little less confusing. And you can see that the intersection occurs right here at 1 comma negative 5. All right, so that's just an alternate way you could do it. But either way, correct answer to this problem is -5. We can do the again. You see do the entire thing in Desmos, in basically under 20 seconds. All right. So for the next problem here, basically finding a point after a translation, we have a graph of a line. It's translated up 7 units, and they want to know what's the x-coordinate of the x-intercept of the resulting graph. Okay, here is one important piece of information that you do need to know regarding translations of functions. In order to do a translation, using the method that I've demonstrated here, the function has to be of the form, y equals everything else on the other side, okay? Or f of x equals everything else on the other side. So the point is, you can't type in 3x minus 5y equals 12 and then just basically do a plus 7 to that to try to shift it up 7 units. So you do have to do some manual work here to put it into slope-intercept form first before you do the translation. So for example, you would have to subtract 3x on both sides. And then you would have to go ahead and divide by -5. Now, after this, I will talk about an alternate way that you could do this, this part technically in Desmos, and show you how you can, and we'll go from there. All right. So now we can do, f of x equals 3/5 x minus 12/5. Just make sure that I've done that correctly. And now we want to translate it up. So we'll do g of x equals f of x plus 7, translated up 7 units. What's the x-coordinate of the x-intercept? Okay, so looking at the black line here, that's a translated function. I get -7.667. Now, if you recognize, really what's happening here is it's -7.6, just essentially repeating. So acceptable answers for this problem technically would also be -7.666. Basically, you're truncating the decimal, or the fraction form, which is just really -23/3. Okay, so either of those would be acceptable as well. Okay, so now the first part, if you did not want to do it by hand, I mean, what you could do is you could technically go to Desmos here. And essentially, what you need to find is the slope and the y-intercept of this line, excuse me, using Desmos. So the easiest way to do that is notice here we have a point 40. Here we have a point 0, -2.4. So the x and y intercepts here happen to be nice. One's an integer, one is a terminating decimal. So what you could do for the first step, if you don't want to do this by hand, basically just go to the table, put in the 2 points. Okay, now we have the equation of the line. So now what I would do, and let's see if this works, it's going to be and I can type the function like this because it's just carrying over the stored values of m and b. So now you could go through the process of where you do g of x equals f of x plus 7, and then we want to know the x-intercept of, and notice we have the exact same point here, -7.667. So this is how you could do the entire problem in Desmos, basically involving 2 different operations. First, linear regression by entering 2 points from a table and finding the slope and y-intercept of the line, because in order to do a translation of a line, it has to be in slope-intercept form when you type it in. All right, so let's look now at some other examples. So other types of problems where you can use translations is basically when you're trying to match a graph, or find an equation of a function from a graph, basically before or after a translation. So let's take a look at this next problem, which deals with matching, the original function to the graph of a new function after a translation. Here we're dealing with a circle, equations given in standard form. So I can just go ahead and graph the original circle. All right, and we have it on the screen right here. And now I can go through my answer choices and I can just type them in and see which one matches a shift, or it looks like the original circle has been shifted left 5 units, up 5 units and left 2 units. So when you do the first one, notice it looks pretty close. It looks like this one has definitely shifted to the left and it's also shifted up a fair amount. So it looks like this may be the correct answer. We can just check some of the others because notice for answer choice B, it is the same except it has, -3 in here. So notice if I do that, it goes to the right. Okay, so that's obviously wrong. So let's send this back here. And now for the last two, if I make this +2, okay, now obviously it's gone down. So it's not going to be C and it's not going to be D. Okay, so B is going to be, A is going to be the correct answer, the original one I had. It's 8 and the +1. And you can see that just by looking at, the graph here. Just type in the original, type in the answer choices, and just visually see which one shows the correct shift. Now, you could also technically, if you wanted to kind of confirm, you could go to the, let's say, the original here. I've got my endpoints in my diameter, 110 and 1 -4, and I could find the midpoint of them. Let's label it. And then I could do the exact same thing for the midpoint, or really what I'm doing is I'm looking at the center of the other circle, -115, -1, 1. Let's label that. Okay, so we can clearly see here it's gone up 5 units from 3 to 8, and it's gone left 2 units from 1 to -1. So if you want to take the time to do this just to confirm, and it's a little easier to see visually because now you have the coordinates of the points, you can do that as well for a problem dealing with circles. All right, so now let's go to the top of the next page. Here we have another translation problem. And basically what's going on here is you have a graph of basically some function y, and this is showing that f of x -3. And we want to know what the equation of f is. Okay, so basically what we want to do for this problem is first find the equation of the line that's given in the graph. Okay, so we could just go ahead and notice it goes through the point here 0, -1, and it looks like it also goes through 3, 0. So I'm just going to create a table. All right, then we're going to do linear regression. All right, so I've got my line, I've got my slope, and I've got my y-intercept. Okay, so now this is f of x -3, basically what I have here. So notice f of x is just going to be this given function, this given line, y, and then +3. So essentially all I have to do is there's multiple ways you could do this. You could say like, okay, g of x equals mx plus b, and then you could say f of x, which is what we're trying to find, is just g of x +3. All right, so now what's the equation of this line here? Well, it's going to have the same slope. The slopes are all the same, so that's 1/3. So really, what's the y-intercept of my translated function? It's +2. So the correct answer we can see is clearly going to be letter C here. Now, you technically, if you just wanted to save time, just do it in all one step. All you'd have to do here is, for f of x, basically just take mx plus b and then add 3 to it to represent, the vertical shift up 3. So there you can see the line again. Because basically what's going on here is, like, you have f of x somewhere like 3 units above this given line, okay? and then you shift it down 3 units, and this new line is the y, right here, the y equals f of x minus 3. So basically you're trying to reverse this and shift it up 3 units. Um, and this is how you could just do it, confirm the answer in Desmos. All right, so that is the end of basically the core, or kind of what I call, basic Desmos skills to be familiar with and to be aware of in order to do well on the digital SAT math section. If you have any questions or comments about the operations covered in this video, please do leave them below. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. And next up will be basically the intermediate skills. And then after that will be the advanced skills. So depending on what your goal is in terms of target score for digital SAT math section, you may want to check out both of those videos. You may only want to check out the intermediate video, or you may not need to check out either of them. So whatever you choose to watch is fine. But just be aware that those other videos in the series are out there for you to look at as well.